In this video, we're going to look at different types of waves and the characteristics of waves. So we're basically figuring out how do we describe aspects of a wave and what can we measure about them. So there's two things to look at here. First, we want to define that a mechanical wave requires a physical medium. So you can't have a mechanical wave if you don't have a medium that is physical. And by medium, we just mean whatever the wave is going through, the stuff. And by physical, we mean that it's made of matter. So examples of this, a spring could be a physical medium, water could be a physical medium, air could be a physical medium, because all of those things are matter. They're stuff, they're physical things that can interact with each other. Now, there's two types of waves. These aren't necessarily required. These are, for all waves, they're not just mechanical, but we're talking about mechanical at the moment. First are transverse waves. And this is where the medium moves perpendicular to the direction of the energy flow. We'll talk about what that means in a second. And the second are longitudinal. And this is where the wave moves parallel, or the medium moves parallel to the direction of the energy flow. So the energy flow is kind of what you can see moving back and forth in the medium. So for example, a water wave, is this kind of pulse that'll move along in the water. So if you imagine this bump moving through the water, the direction of the energy flow is left and right. But if we look at the medium itself, the water isn't moving left and right. The water itself is just moving up and down. So this kind of up and down wave is an example of a transverse wave, because there's some bump that's moving across. Well, that means the individual parts, like the individual atoms or molecules of water, are just moving up and down to create this bump to flow through. Longitudinal waves are, the easiest example of this is from the lab, the slinky. So at the slinky, you're going to have some sort of appearance. And this is backwards from what you saw in the lab, but you get the idea. So we've got the slinky as, either compressed or stretched, and then there's some section of it that's the opposite, either compressed or in this case stretched. And that compression or that stretch is going to move back and forth through the medium. And if you look at individual coils, the coils themselves are going to move back and forth through the medium. So in other words, they're moving in the same direction, they're moving parallel, and so this would be a longitudinal wave. So the other way to think about it is longitudinal waves are the ones where the medium goes back and forth, and transverse waves are the ones where it goes up and down, if we're assuming that the energy flow is back and forth, left and right. But really what you need to have in mind is it's comparing the direction of the medium movement to the direction of the energy flow. If they're parallel, longitudinal. If they're perpendicular, transverse. Now that we've defined that, we can talk about the different things we can measure about a wave. So there's a bunch of things that we can measure. The first is amplitude. And this is the maximum displacement of the medium from its rest from position. So wherever the individual particle or coil or whatever it is that the wave is passing through, wherever that would normally be, however much things get moved when the wave is kind of at that point, the maximum, that's going to be our amplitude. And this will make more sense when we show a diagram here in a minute. It'll probably help flesh that out. Next, we have frequency. And this is how frequent the waves are, or another way of thinking about it is the number of waves or cycles for a given amount of time. So in 5 seconds, how many waves go by? Or in 5 seconds, how many times does this go through a complete cycle? Next, we have the period. And this is the amount of time it takes for a given one single wave or cycle to pass a point. And then lastly, we have velocity, which can also mean a speed. And this is how quickly the energy passes through the medium. So let's take a look at a diagram of a longitudinal wave, or sorry, transverse wave, where we can talk about this. So X right here, let me change the color so it stands out a little bit better. This X right here is the amplitude. Because if you look, this dotted line is kind of like where the water would normally be if there were no waves. And so the farthest that it goes up or the farthest that it goes down is our amplitude. And amplitude is technically the absolute value of these numbers. We're not going to worry too much about it in this class, but know the amplitude is just a displacement absolute value. So you'll notice if you have a wave like this that's transverse, between the highest and lowest points, that's actually twice the amplitude, because we're measuring just the distance from the standard point. I realized we actually left off wavelength on the previous one. So let's add that in. So wavelength is the distance between identical positions or points on adjacent cycles. And this is a weird technical definition because we need to be kind of precise in our language. But practically speaking, it's easy to know as just the distance between two peaks or the distance between two low points. Those are both going to be your wavelength. And we typically represent that with this character lambda. And its wavelength. One thing to note that gets a little confusing is even though these are at the same height, they're not identical points, because if you look, one is kind of an uphill, the other is a downhill. And so the wavelength would actually be between the uphill and the next uphill, which ends up being, you can kind of see here, the same as the wavelength. It's the distance between the peaks or the valleys. Here we've got our velocity, which by this point hopefully you're pretty familiar with. And that's basically if just you imagine watching the peak and seeing how far it goes and how long it takes to travel that distance, you can calculate a velocity. Frequency and period, we can imagine if there's like let's actually imagine at the seagull here. So frequency would be if the seagull's counting, say, to 10 seconds, and they count how many times do they go up and down. Because each time they go up and down, that's a wave. So going up, coming back down, that's one wave has passed. So if the seagull's sitting here and after 10 seconds, 3 waves have passed, we'd say that the frequency is 3 waves per 10 seconds. Or if you want to make that waves per second, it would be 3/10 of a wave, 3 out of 10 waves every second. And that's just from dividing the 3 waves in 10 seconds is the same thing as saying 3/10 of a wave every second. On the flip side, if the seagull counts how long does it take to go up and come back down, that would be the period. So however long it takes for it to go through one complete cycle, that's the period. So these are the characteristics of a wave. At some point we'll look at how they're related, but for now just worry about kind of how we measure them and how they're depicted and what they mean.